Hi guys, welcome back. Today our topic of discussion is the division of the periodic table into various blocks. So what we have here is the periodic table. The periodic table is actually divided into 4 blocks. What are these 4 blocks? I have already told you. This is the S block, the P block, the D block, and the F block. Okay, so these are the 4 blocks of the periodic table. Now these will lay your foundation of inorganic chemistry. Okay, in an inorganic chemistry, whatever you will study, you will only study about these 4 blocks and the properties of elements in these blocks. So let's start. First we will get an introduction of these blocks in the periodic table chapter, then in various chapters we will cover the S, P, D and F blocks separately. Okay, now in the S block, what we have got here, how the elements are classified into S block. The elements are in which the last electron enters the S subshell of the outermost energy level. What we know here is the last electron, which in the electronic configuration, if we write, the last electron will enter into the S subshell of the outermost energy level. Okay, so where is this S block located? In the extreme left of the periodic table. This is the S block. In the extreme left of the periodic table, group 1 and group 2 consists of the S block. This group 1 is actually known as alkali metals, and group 2 is known as alkaline earth metals. These two groups are constitutive of the S block in the periodic table. Now let us look at some general characteristics and properties. Firstly, it is the electronic configuration. General electronic configuration is NS122. You must have learned it in your atomic structure class. Now let's look at some characteristics. So these are soft metals. They have low melting and boiling point. These group 1 metals and group 2 metals are actually soft and have low melting and boiling points. They are very reactive. They react even with water found in the evaporated state in the air, and they are coated with their oxide if we keep it in open air also. That's why it is kept, these S block elements are kept inside kerosene, or they are wrapped in paraffin paper, and then they are kept because they are so reactive. They do not occur in their native state, like gold, silver. These occur in their native states in nature. Actually, you can find gold from the earth, find silver from the earth, find platinum from the earth. You cannot find sodium from the earth. It will always occur in the combined state in the reactor. It is because it is very reactive. It will never occur as sodium in earth. So oxidation states +1 and +2. +1 is for alkali metals, +2 is for alkaline earth metals. They are very good reducing agents. Why? Because if they are kept in their natural form, they will always try to react and achieve these +1 and +2 oxidation states. So they will oxidize themselves, and they are reducing the whatever they are reacting with, they are reducing it. So they are good reducing agents. They are predominantly ionic in nature. Now see, we will start with the P block. A P block is similar to S block. The elements in which the P block elements, their last electron enters into the P subshell of the outermost energy level. Similar in the S block, it entered into the S subshell. Now it will enter into the P subshell. Where is the P block located? P block is located in the extreme right here. These group 13, 14, 15, 16, 17 and 18, they constitute of the P block elements. Now the P block is most diverse period or block of the periodic table. Why? Because it constitutes of metals. These are all metals. These orange ones are metalloids. Rest of these are non-metals. This is the only block which contains non-metals, metalloids as well as metals. Others, it only contains metals. In this P block, it is the most diverse. That's why it is the most diverse block of the periodic table with various properties. Its properties ranges vastly. Now there is one catch in this p block elements. One problem is there, which is with this element. This is helium. Now what is the electronic configuration of helium? If we know, it is 1s2. Now you can see where the problem is. The problem is that it is entering into the s subshell. The last electron is entering into the s subshell. So helium is strictly an s block element, but then why we haven't kept it here? Why have we kept it in the noble gases? Because the properties of helium, as the last energy level is completely occupied, the properties of helium are very much similar to the rest of the noble gases. That's why and what is the motto of classification that we know? We want to classify based on properties, not on the based of blocks or on the based of electronic configuration and all. We want to classify based on properties. That's why we have kept helium in the noble gases in the p block, but it strictly belongs in the s block group of elements. Certain characteristics of p blocks. The general electronic configuration, as we know, is ns2 np1 to 6. What are the characteristics? The characteristics are very varied. That's why I have told you this is the most varied, most diverse period of block of the periodic table. So it shows variable oxidation states, forms both ionic and covalent compounds. Most of them are non-metals, and that's why that's form acidic oxides. So what are we have learned? The s block is mostly ionic, and they are metals, and they are very reactive reducing agents. So a p block, they are mostly they can be both ionic and covalent. They are mostly non-metals and form various variable oxidation states compounds. Now let's look at the d block. The d block are the elements in which the last electron enters into the d subshell of the penultimate energy level, not the outermost energy level, because we know because of the n plus s rule that the s block just after the d block becomes lower in energy than the d block itself, the d subshell itself. So the d subshell, it gets filled after the s subshell of the corresponding the orbit. So the electron will enter into the penultimate shell rather than the outermost shell. Now let's see where the d block is located. This is the d block here. It is the largest block of elements in the periodic table. Is the largest block. It consists of these 4 periods, and here the 3d, 4d, 5d and the 6d these series are filled. Look at the properties of and characteristics of d block element. The general electronic configuration is n minus 1 d1 to 10, n is 0 to 2. What are the characteristics? They are hard, high melting metals. All of them are metals. They are hard and high melting point, have high melting point. They form compounds with variable oxidation states. They also form colored complexes. This is very important because it helps us to identify which metal is there in salt analysis. These colored complexes, they form ionic as well as covalent compounds. They possess catalytic property. Catalytic property means they can accelerate a reaction for both forward and backward directions. Then this property we will study more in d block. Now just know the name. It is known as catalytic property. They form alloys. What are alloys? Alloys are mixture of various metals, which have better properties than the metals itself. So they form alloys also. They are good conductors of heat and electricity. That's why they are of daily use as well. Now if we look closely at the position of this d block, we'll see in one side we have these highly reactive s block elements, and on the other side we have these less reactive metals of the 13th and 14th. So what is the d block doing? It forms a bridge kind of between the highly reactive and the less reactive metals. That's why it is also known as they are also known as transition elements. Transition means forming a bridge actually. Transition elements, they are also known as transition elements because they form a bridge between these highly reactive S block and the less reactive 13th and 14th group metals. Now if you look closely here, Zn, Cd, Hg, these three metals, zinc, cadmium and mercury, they actually are outliers as they do not actually show most of the properties of the d block elements like the rest of them, because of only one thing: they have completely filled d orbital, d10. They have completely filled d orbital, so they mostly show their own characteristic properties. They do not follow the properties of the other d block elements. Now, as the d block is known as transition elements, these S and P block similarly are known as representative elements. Representative elements. The S and P block are known as representative elements and the D block is known as transition elements. These are just the nomenclature that we have done. It is not very important, but you should remember. Before going to the F block, there is another thing that needs to be pointed out is hydrogen, the position of hydrogen here. Hydrogen's electronic configuration is 1s1, which means that it should be placed here in the first group. But what happens is the hydrogen also shows the properties of this 17th group element. So there is a confusion between the scientists as to either place it in the first group or the 17th group. That's why it is, due to this controversy, it is present. It is outside of the period as a separate element. Let's look at the F block elements now. The F block elements, the elements are actually in which the last electron enters in the F subshell of the anti-penultimate shell. What do you mean by anti-penultimate shell? If we see, let's take this 3 to be the shell. This is the last cell. This is known as the penultimate, where we have come across this in the D block, and this is known as the anti-penultimate. So the elements in which the electron will enter into the F subshell of the anti-penultimate shell, that is known as the F block elements. This is also due to the fact, this is the N plus S rule, the energy of the last cells S block and P block elements, last subshells, S block and P block subshells, actually become more less than the anti-penultimate shell F subshell. Well, if we look at the F block is actually present below the main periodic table. In this, outside of this periodic table, these two groups, these are the lanthanoids and these are the actinoids. Why are these names? Because they follow this element. Lanthanum is this element, so the elements that follow lanthanum are known as lanthanoids. This element is the actinium. Whichever the elements that follow the actinium is known as actinoids. Now, what are the properties of these elements? The general electronic configuration is n-2 F1 to 14, n-1 D0 to 1, ns2. This is the general electronic configuration. What are the characteristics? They have variable oxidation states just like D block. They are high melting metal just like D block. They have higher densities than D block. They also form colored complexes just like D block. The actinoids here are actually radioactive. Because of their radioactivity and very less is known about them, that's why we don't know the chemistry of these actinoids in very much detail. That's why we don't have to study them in detail as well. These F blocks are also again known as inner transition elements because why? They are between the first and the D block element, first S block and D block elements. That's why they are known as inner transition elements. Now this concludes about these blocks and all. Just study these. These are not very important because in later we will study this in much greater details. This is just an introduction of what we have to study in inorganic chemistry. This is the only thing we have to study in inorganic chemistry, that is the flux and these characteristics of these various elements in these blocks. Now if you have any doubts regarding this, you should write it down below in the comments, like and also subscribe the videos. Thank you.